Okay, today we're doing the notes for arithmetic sequences. I know we've talked about arithmetic sequences before, but now we're going to look at a different part of it, kind of look at it a little bit more in depth. So, a reminder, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant. What that means is here are our terms. This is the first term, this is the second term, this is the third term, the fourth term, and the fifth term. And between them, they are constantly being increased by 4. So because they are increasing or decreasing, but in this case, because they're increasing by a constant term of 4, that means this is an arithmetic sequence. So there's two different formulas for this. There's the recursive formula. And the recursive formula is the one we talked about earlier, where it's used to find the next term. And the recursive formula, we say an, the previous term, an minus 1, plus d, which, reminder, is the difference. So in relations to this problem, let's say I want to figure out what the fourth term is. I would say or let's say I want to figure out what the sixth term is, right? I'm going to say a6 equals a6 minus 1 plus my change, which is 4. Well, 6 minus 1, that's 5. So I look at my fifth term. My fifth term, A5, is 19. So this is A6 equals 19 plus 4. 19 is my fifth term. 4 is my common difference. And 19 plus 4 is 23. So A6 is 23. Now, that works great if you know what the previous term is. However, there are plenty of times, like in this problem, I could say, okay, what's the 20th term? Well, using this, I would have to find the sixth term, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th term, then just to find the 20th term. Instead, we have this other formula that's called the explicit formula. And what that means is it's used to find any term in the sequence. So here's how it's written. We say an, which is the term we're looking for. We take the first term, we add the common difference, and this, that's supposed to be D right now. And then we take n minus 1. And this is the time when we're not talking about a term. So let me go ahead and put it in the context of this. And let's say I'm looking for that 20th term. So let's say I'm looking for that 20th term. I look at my first term. My first term is 3. A1 is 3. My common difference every single time is 4. So I'm going to say plus 4. And in this case is 20. So 20 minus 1. Well, 20 minus 1 is 19. So this means, I'll rewrite it over here. A20 equals 3 plus 4 times 19. 4 times 19 is 76. So A20 equals 3 plus 76. And A20 equals 3 plus 76, that is 79. So that's how I find any term that's just sent out there. This is great for finding the next term in the sequence because the math is a little bit easier. This is great for when we have to find a term that's way out there, like the 20th term or the 30th term or something like that. So let's go ahead and look at these examples. It wants us to write the next 3 terms, all of these to write the next 3 terms, write the recursive formula, so this one over here, write the explicit formula, so this one over here, and then find a term that's way out there, 39th, 100th, and the 25th. Okay, so the very first thing I need to do, this is my first term, this is my second term, this is my third term, this is my fourth term. And this is changing by 7 every single time. It's increasing by 7. So to find my next 3 terms, my fifth term, 26 plus 7, that is 33. My sixth term, 33 plus 7, that's 40. And my seventh term, 40 plus 7, that is 47. So those are my next 3 terms. The recursive formula, and reminder, the recursive formula is an equals an minus 1 plus d. This an and this an minus 1 won't change at all. But what will change is d right here, which is the common difference, how much it's changing by, and it's changing by 7 each time. The explicit formula, I'll write out the normal version first. It's an equals a1 plus d, and then n minus 1. A1, I know in this problem, my very first term, it's 5. So an equals 5 plus my common difference, which it's increasing by 7 each time. So these two will always be tied to each other. And then this is n minus 1. And now that I have my explicit formula, now I can find my 79th or 39th term, excuse me. So A39 equals my first term 5 plus 7 equals 39 minus 1. 39 minus 1 is 38. Believe it or not, Mr. Austin does not know 38 times 7 off the top of his head. It looks like it's 266. So 5 plus 266, which is 271. So if you notice with these problems, I'm going to cover this last one first because it's going down, and so I want to show that subtraction. But what you notice is none of these you have to test to see if it's an arithmetic sequence. All of these arithmetic sequences are going to be given to you. It's just you have to find the formula. So there you go. This one's going down by 4. So the next 4 terms, this is the first, second, third, fourth, fifth. So my sixth term, that's negative 11. My seventh term is negative 15. My eighth term is negative 19. My recursive formula, I'm going to rewrite the original formula, which is an equals an minus 1 plus d. This is changing and going down by 4 every single time. So an minus 1. You could either write minus 4 or plus negative 4. Either one is perfectly fine. The explicit formula, this is an equals a1 plus d and minus 1. So an equals my very, very first term, which is 9, plus a negative 4 and minus 1. And then I asked for the 25th term. So now I'm going to plug 25 in for n because that's the term I'm looking for. So a25 equals n plus negative 4, 25 minus 1. So this becomes 24. 25 times 4 is 100. So 24 times 4 is 96. So this would be 9 plus a negative 96. 9 plus a negative 96 equals a negative 87. All right, I'll go ahead and go through this last one. I'll go through it rather quickly because this is the third one we're doing. If you want to pause the video and try it out on your own and see how far you can get, and then come back to the video to double check yourself, that would be great. This is increasing by 10 every single time. So my next three terms, this is 1, 2, this is 1, this is 2, this is 3, this is 4. So I'm looking for the fifth term, the sixth term, and the seventh term. The fifth term would be 46, the sixth term would be 56, and the seventh term would be 66. The recursive formula is written as an equals an minus 1 plus d. So let me go ahead and rewrite this using our information in this problem. An equals an minus 1 plus, looks like it's 10 because it's changing by 10 every single time. The explicit formula starts off as an equals a1 plus d n minus 1. And I'll write an equals my very first term, which is 6, d, which is 10, and then n minus 1. So finding the 100th term, I'm going to say a100 equals 6 plus 10, 100 minus 1. 100 minus 1 is 99. 100 times or 10 times 99 makes 990 plus 6 is 996. This concludes our notes for the arithmetic sequences. To fold this, you fold this part up to here, and then you fold this part down to here. And there you go. That's the notes for arithmetic sequences.